In this video, we look at an example of finding a vector function that represents an intersection and then are being asked to figure out the length of that curve. So we were given the cylinder 4x squared plus y squared equals 4 and the plane x plus y plus z equals 2. So we want to parameterize the curve of intersection and then find the length of that curve. So probably the easier piece of this to parameterize is the 4x squared plus y squared equals 4. If we plug in cosine of t for x and 2 sine of t in for y, we get a parameterization of that ellipse. And then using the x and y in terms of t, we can figure out what z is. So in this case, the z will be 2 minus cosine t minus 2 sine t. We notice that the ellipse that we parameterize gets traced out exactly one time on the interval from 0 to 2 pi. So that's exactly what we're going to integrate over when we compute our arc length. So we've now found a parameterization, or a vector function if you will, that gives us the length of the curve. We know the interval over which we're going to trace out that entire curve, so we can use our arc length formula and integrate from 0 to 2 pi the magnitude of the derivative, dt. The derivative of cosine is negative sine, derivative of 2 sine t is 2 cosine t, and the derivative of 2 minus cosine t minus 2 sine t is just a sine t minus 2 cosine t. We can square those things out and simplify to this, but this is not something that's easily integrated. So let's just approximate it using graphing calculator, computer algebra system of your choice, whatever, and get approximately 13.5 as the length of this curve.